Let's talk about a problem now where we use both the rules. This is usually a problem that has more than one power supply. So, and it's also sometimes hard to tell if things are in parallel or series, so you can't just do a simple analysis. The first thing we need to do is look at the problem and identify the junction rule. So according to this, I2 goes into B, into this junction right here, which I've called B, and it splits up into I1 and I3. So I2 equals I1 plus I3. The next thing I'm going to do is I'm going to use those current directions to identify the positive and negative polarities of the resistors. So the current is going to always flow down a hill from the high end to the low end. So it goes through the resistor to the right, and as it does that, it goes from positive to negative. So positive on the left side, negative on the right side of R3. I2 is going up through R2, so positive on the bottom, negative up top, and positive on the right for R1 and negative on the left. That's the first thing to do. I don't have to do anything for the batteries. I already know what those polarities are. Next thing I do is I go ahead and label my junctions, A, B, C, D, E, F, whatever naming scheme you want to. All right, now I'm going to apply the loop rule. So I'm going to pick a loop. I have three unknowns here, and I need to have three equations so that I can rearrange and find one unknown, plug into for it, and another one, find another one, and so forth. So I could do the outside loop if I want to. I could, A, C, D, F, or I could do the A, B, E, F, or I could do B, C, D, E. Whatever loops I do, I need to go in the same direction. So if I'm going clockwise, they all need to be clockwise. So let's do loop A, C, D, F. So that's the outer loop. So if I do that, if I go around, I'm going from across R1 from positive to negative. So that's a loss in voltage, and it would be 4 times I1. So minus 4 I1. And then I go through R3, and it loses a voltage of minus 1 I3. You go through B2, and that's going to be a loss too, because I'm going from positive to negative. So minus 7. I go all the way around, and I'm going to have a gain of 28. And all that is adding up to 0. And I can simplify that to be, if I put the i's on the other side, and I keep the numbers on the left side, it's going to be 21 equals 4I1 plus I3. Okay. All right. Now let's do loop A, B, E, F. A, B, E, F. So I start at A. I'm going to lose 4 I1. And then I'm going to go from B to E. I'm gaining. So I'm losing 4 I1. And I'm gaining 2 I2. And I'm gaining 28 volts. So if I rearrange this, it would be 2I2 minus 4I1 equals negative 28, like that. And then I can do loop B, C, D, E. So from B to C, I'm going to lose I3 times 1. And I'm going to lose 7 volts. And as I come back around, I'm going to lose I2 times 2. And why is that a loss in this one? Because as I go around from E to B, right, I'm going up like this, so I'm going from positive to negative, that's a loss. In the other loop, I was going down through it, and it was a gain. So, where do I start? Well, I know what I2 is, and I could substitute I2 in any of these equations that get and get rid of I2 and get it in terms of I1 and I3. And I think I'm going to do that with this one right here. So if I rearrange this, this is going to be negative I3 minus 2I2 equals, I'm going to put 7 on the other side, add 7 to both sides. And I2 is I1 plus I3, so negative I3 minus 2 times I1 plus I3 equals 7. So this is going to be negative I3 minus 2I1 minus 2I3 equals 7. And so if I get my i's together, right, I3, this is going to be negative 3I3 minus 2I1 equals 7. So I have another equation here that has I1 and I3, and I can solve for I3 here. I3 equals 2, 1 minus 4I1. And now I can plug that into this. Negative 3I3 minus 2 times 21 minus 4I1. Oops, I just screwed that up. I plugged in for the wrong thing, didn't I? I'm plugging in for I3. So 3 times 21 minus 4I1 minus 2I1 equals 7. So 3 times 21 is negative 63. Negative 3 times negative 4 is plus 12I1 minus 2I1 equals 7. So if I get everything together here, my i's are going to be 10I1. I'm going to add 63 to both sides. So 63 plus 7 equals 7D. So I1 equals 7 amps. Now I can find I3. I3 equals 21 minus 4 times 7. And that's going to be 21 minus 28. I'm sorry, I'm having a brain fart. What is 4 times 7? Yes, it's 28, my bad. 28. 21 minus 28, which is going to be negative 7 amps. Now, what does that mean? It means that I3 is actually moving this way. That's what it means. When I go to find I2, which is I1 plus I3, I'm going to plug in the numbers exactly the way they come up. A 0. So there really is no, in this circuit, there is no current going into R2 at all. Kind of a weird one, but it's the way it works.